Hi, this is Mike Frank, and I'm welcoming you to the MySQL security model in the Oracle Cloud for the MySQL database service. I am a product manager, management director for MySQL, and my co-presenter, Harin, is our lead security engineer. So just before we get started, we want you to know that we want to hear from you. Please feel free to ask any questions in the Q&A chat at any time, and an expert will be on standby ready to answer your questions. And if time allows, we'll also answer some questions live at the end of the session. So today, Harin and I will be co-presenting, and I will start off with the OCI security features and concepts. And after that, Harin is going to follow me with details on the MySQL database service, or as we may call it, MDS at times. It's important to understand each of these to really understand the sort of security state for the MySQL database service. So with that, I'm going to go into it. So I think one of the first things to realize is that OCI, the whole design of this Gen 2 cloud is security first. We redesigned the virtualization stack to reduce the risk of hypervisor attacks, increase tenant isolation. This design really is the best way to secure a cloud. And so this cloud is really a big improvement over the first generation clouds. And this design is implemented across all the Oracle Cloud infrastructure. Obviously, the MySQL database service is designed on this technology using tenants, controls, all those things that make the Oracle Cloud very, very secure. So just a note, and I won't spend much time on a couple of these slides, but enterprises are struggling with the cloud security, and we don't want enterprises to struggle, and we want things to be simple. And they're struggling because there's a lot of things to really worry about, right? There is just so much going on, and so really, the DevSecOps is very, very important. Criminals are just stealing more and more with via credentials or phishing attacks or all the different sorts of things that are going on. So, a lot of organizations are sharing cloud accounts and things that really shouldn't be going on. So we really want to help battle against these threats, right? And so what we're going to talk about is how really we're going to reduce the threats to your data, to your applications in the Oracle Cloud. So first, there is a challenge with Gen 1 clouds, right? There's a lot of security tools. There's not many instructions on how to put it all together. There really is not enough isolation in how they're architected. And the customers just got to integrate and cobble together everything. And this complexity really makes it difficult to tell if you're really secure or not. And if you don't know you're secure, that's a problem. So we kind of got a different take on our cloud design. Our principle was, let's just make it like a vault, right? So a vault, right, its primary design driver is to be secure, right? So it's built in, you'll have monitoring, you'll have all these sorts of things. And then, you open the door to the vault when it's needed and only for who it's needed, right? So let's drill down and sort of how this vault type of thinking manifests itself in the Oracle Cloud. So we have basically a zero trust model. And what that means is that you look at having trusts as a vulnerability. Basically, you want to minimize how many things have to trust other things. In that way, really, you isolate, you segment off things, and you have a very granular level of security at all the layers. So you've got access controls, cryptography, secure DevOps, secure operations, there are all sorts of things that go into this. And so now let me sort of dig into how OCI and MDS allow you to have this principle of least privilege and how we enforce that across not just MDS, but really all OCI cloud services. So first, let's look at the network, right? So we have isolated network virtualization. It's very secure firmware installation. We have controlled physical networks, and we have network segmentation. All of this really reduces the risk of, by decoupling network virtualization from the hypervisor. In the traditional clouds, traditional virtualization environments, hypervisors manage the network traffic. And there's a lot of risk that comes with that design, because when that happens, if you can use the hypervisor to exploit the network, and you can break out of a virtual instance, for example, and access underlying operating systems and gain control of the hypervisor. With our Oracle Cloud, we reduce this risk by decoupling the hypervisor and the network virtualization from each other. So this isolated network virtualization reduces the risk by really eliminating the attack surface, right? And that limits your risks a great deal. The other thing to notice is that we also reduce the risk of firmware attacks. So we have this root of trust technology. We designed it to wipe and reinstall the firmware every time a new server is provisioned and a new customer tenancy is established. So each server's pristine, from the get-go. We start clean. It's never been tainted in any way that might reduce the level of security. So this is sort of we don't trust anything when we start all the way down at the firmware level. And in theory, it's possible that the firmware on these servers has been compromised, in transit by a manufacturer or somebody like that. So we clean these things so that that you have a golden version of the firmware, and that's on all things. So it could be network devices, it could be hardware, computer hardware, it could be network switches, all these sorts of things. We apply that principle. Next is network isolation. So isolation, for your workload from any other workload. So we have virtual firewalls at the subnet level. We balance traffic, right? So, so that things can't be any denial of service or clogs up in your network level there. The communication between availability zones is encrypted with MAC security, and I'll talk more about that in a little bit. And for security, no VCN has internet connectivity by default. You have to enable that. And so, and then there's just, again, web application firewalls with 250 predefined open OWASP standards and various compliance rules in there. So again, you've got a ton of security there just from the get-go that will protect your assets, and especially the MySQL database service. So connectivity-wise, we limit access to these production systems. So there are multiple authentication layers, and it's really compulsory to have a virtual private network connectivity to the production network. So we enforce high password diversity. We use UTF, universal second factor authentication. And finally, when the customer does require to connect to the Oracle Cloud from their tenancy, and most do, there's a couple of ways to do that. You can use an IPsec VPN, a dedicated encrypted tunnel, and route that between the networks, or you can use our Fast Connect, which is a private, high-speed WAN connection with an optional IPsec VPN tunnel. So let's drill down a little further. So here we're using MACsec for connections between data centers. And so MACsec is a very high speed, and it's a layer 2 network encryption protocol versus a layer 3. And so this is important because it protects traffic such as DNS, ICMP things that aren't covered by a traditional layer 3 encryption. So it can not only protect the IP traffic, but also ARP, neighbor discovery, DHCP. It relies on GCM, AES encryption to make sure everything's confidential. And so anyway, it's really good to have this layer 2 protection. And, you know, from history, things like Meltdown and Spectre showed that shared resources are a risk to security, and things like MACsec really help prevent that. Next, right, it's about processes too, right? It's about making sure that the code that we roll out is good. And so Oracle has huge teams of specialty security professionals that assess the security strength of the infrastructure, the products, the services. We went through many iterations with them on the MySQL database service. There's security scanning going on all the time, that we check things out. We run pen tests. We do ethical hacking. So all that sort of stuff is built into our process and done continuously so that you know that your MySQL database service is secure. On the physical security, we have all the, you know, standard sort of guns, guards, and gates with all the ANSI, N2, data center durability cameras with two-factor authentication to get into the facilities, time-bound access for individuals. So it's very strict, and you know that you've got physical security with us as well. So sort of to sum it all up, I'll use the bank analogy. So do you want the bank that's, you know, just got one locked vault door, or do you want the one with a locked door and an alarm system and an arm guard and all these sorts of things that really make it secure? Well, if you look at all the things that we have in our security control, you can tell we've got a lot here, all the way to bare metal level. And you know, you're only as strong as your weakest link, and we've got a lot of strength, and we've got strength in many layers, right? So security is about many layers, and it's about isolation. So next, I want to take a few slides to explain our terms. I think it's important that, you know, if you don't understand a term, then it's a little hard to understand maybe what we're talking about. So at the high level, we've got a realm, right? And this is based on a sort of a regulated market. So right now, MySQL database service is in the OC1 realm, and OC1 realm is for commercial software. But there are other realms like FedRAMP realms. I think there's 8 now. And then there's a region, right? And that's a localized thing. So, so OC1 realm spans many regions, and MySQL database service is in many regions. So we're in Ashburn, Phoenix, Frankfurt, Tokyo, and I probably even left some out because more and more emerge and are announced every day. We're rolling things out across the world very quickly. And then finally, an availability domain. And so this is there's one or more ADs, data centers located within a region. And so, and then within that region, you've got this low latency, high bandwidth between these availability domains. So this makes it possible for you to build replicated systems with mutually available domains in different data structures, data centers. And finally, within an availability domain, you've got a fault domain, and that's a grouping of the hardware and the infrastructure. This is so that we know that we're putting things on unique, you know, on different racks. So there's this anti-infinity to assure that everything's distributed out. And this is good for high availability, but it's also a good thing for security as well. So sort of sum things up, there's levels of isolation to provide security protection at each level. Fault domains protect failures in the ADs. ADs protect regions and regional pairs, which is our goal to have regional pairs in every country so that you have another data center to fall over to. And we plan to have a minimum of 2 regions in almost every country where we operate, so that you've got this very high availability capability. And if one region is lost, you can fail over the other region within a country. So when you sign up for Oracle Cloud Infrastructure, we create a tenancy for your company. This is a common term used by many, and within the tenancy, you're going to secure and isolate. It's a secure and isolated position for your company where you can create the things you need, right? Including the MySQL database service. So within, so the resources in OCI, you've got your compute instances, your databases and services and things like that. And so basically, and you have a root compartment right at the top level. But really what you want to do is you want to sort of create isolated compartments so that you can isolate your own resources from each other. So a compartment is really a collection of related resources. It's a grouping, right? And so you create these groupings, and then you can, and resources can interact with different compartments. But for each compartment, you can sort of set security controls and things like that. And you can nest these compartments too, so that things can't, you can work intercompartmentally, I would say. So that's sort of a, quick run through of things on sort of at the OCI side and on the terms and such. Now I'm going to turn it over to Haren, and he's going to talk about the MySQL database service.
Thank you, Mike. So that was overview of OCI security aspect. I'm now going to drill down on MySQL database services security aspect. But before we do that, before we dive into that, let me give a quick recap about MySQL database service itself. So MDS is a fully managed OCI native service. It's 100% developed and managed by MySQL team, and this includes service-side infrastructure such as REST APIs, DevOps tools, console, to the database-side infrastructure such as enterprise server, automated backup, high availability, and the tools engineered to support data import and export. Many innovations done within MySQL 8.0 have been driven by MDS's requirements. And all of this have been released in on-premise releases as well, which allows us to have 100% compatibility between on-premise version and MDS on OCI. The service is staffed 24/7 by MySQL team. They monitor various aspects of health of various MySQL instances that are running in MDS and are available to help if any issue is detected. Any version that we deploy on MDS is thoroughly tested for compatibility, and we make sure that security patches are applied automatically across minor versions without any intervention from customer side. So let me move on to the next slide now. So MySQL database service uses a shared security model. As a customer, you control the data region where your data resides. Relational schema modeling, of course, how you design your query, how you make query optimization, and policies and levels to control who can access your database in what all manner. The rest of the things, ranging from the guest OS to physical infrastructure, is handled by MySQL database service. It's plain and simple. Now let's take a look at security aspect of MDS. This basically based on 3 simple principles: leveraging OCI's secure architecture, always using secure configuration for the database, and secure the database from the word get-go. And in coming slide, we will see how these parts work together to achieve a secure experience for customers. So moving on, MDS run in its own tenancy, which is very restricted tenancy. Any ingress egress is highly restricted. the policies are very stringent that protects your database from any unintended access. There are only two ways to get the access: through MySQL as a service APIs, the REST APIs, or the console, which will execute certain workflows on the database server, which uses a software agent, or for the customer through an SQL connection through the port that is exposed for the MySQL instance. These are the only two ways. There is no other way to access the MySQL, the server on which the MySQL server is running. Now, let me go to the first part. MySQL database server provides APIs through which various operations on the database instances are managed. These operations can be performed through Service Console as well as the REST APIs. They do not provide direct access, as I said before, but they operate through control plane, which provides an interface to execute required operation on one or more underlying DB system. Now, the service APIs are well integrated with OCI's identity services itself. This means that it is possible to configure a very fine-grained control over who can access what in your tenancy or in your compartment. Access can be configured at tenancy level, compartment level, even at various operation level at all those time. Let me give some specific example in one of the coming slide. If we can move on to the next slide, Mike. Yeah. So these are some of the examples of how various policies can be defined on groups. So an administrator group may have access to all instances within a tenancy, or the access can be restricted to a specific compartment using in-compartment clause. Further, access can also be restricted based on the operation. A backup admin may have access to the entire tenancy, but the operation that the backup admin can perform are nothing but the backup related ones. Or, well, an auditor can access a given compartment, but can do nothing except listing all the DB systems within the compartment. So users can be part of one or more groups, and these policies automatically are applied to them as well. Moving on. So a MySQL instance running in MDS is not going to expose a public IP. We leverage on OCI's virtual cloud networking infrastructure, and the endpoint is accessible only internally. The reason for this approach is quite simple. We want to make sure that any configuration error, even if there is one, do not result into data breaches at all. There are quite a few examples of such things already out. So when you create an instance, before you can actually go ahead and create an MDS instance, a virtual cloud network must be created to access MySQL endpoint. Now, it is possible to define policies to suit your needs as well. For example, as you can see on the screen, MySQL endpoint is configured to use 10.0.0/24 IP range, and two ports, 3306 for the MySQL Classic connection and 33060 for MySQL X protocol are used to allow TCP access to the MySQL instance itself. Don't forget that over and above all these restrictions, the default MySQL connections always use TLS encryption. So you're bound to have security at connection level in any case as well. Now, if you wish to access the database over internet, it is also possible through VPN, as Mike already told in his part of the presentation. What we can do is OCI supports creation of a VCN with two subnet, private part as well as the public part. The private part attaches itself with the MySQL instance, and the public part attaches itself with the VPN. OCI supports software-based VPN through OpenVPN, which can be used in combination with the VCN to allow access to the database over the internet. Use of VPN ensures that even though the traffic flows through internet, it is always secure. Again, even with this scheme, the MySQL server endpoint is never exposed. So now that was the first part, how MDS leverages OCI's security infrastructure. Now let's take a look at the second part, which is the secure configuration. MySQL configuration variables are protected based on their nature. There are some which are truly immutable till the time an instance is up and running. This involves variables which are mostly related to files because these are managed internally by MDS itself. Then there is another class of variable which can be set at global level, but through control plane, through a REST API or through the console, not directly. For example, password policy related variables are does fall in this category. And then there are variables which can be set at session level once a connection by client is created. For example, auto increment or char set values or collision. All these things can be set at session level. The global configuration of all variable is persisted, which means that they are stored within data directory itself. And by that virtue, they are as secure as your data itself. There are no separate configuration file like my.cnf, which are used with MDS. We heavily rely on persisted variables itself. Further, depending on various shapes that are available on MDS, certain variables are tuned to give you the best possible performance. An example of this is InnoDB's buffer pool size, which setting is driven by memory available on any given shape. Now, moving on to the third part of security triad, and that is the secure database. So database is created secure by default. When you're creating a database instance in MDS, you as a customer have to provide an administrative password that fulfills the password validation criteria, and by that virtue, it has to be very secure. It needs to have all the typical restrictions that you can think of, the number of characters, the type of characters, special characters, digits, all those things. Data on the disk is encrypted at rest because storage technology behind it provides such a protection by default. So is the backup, not just a running MDS instance. The backup itself is secure as well. Password validation plugin makes sure that password satisfy compliance criteria. Use of connection control plugin by default towards brute force attempt to crack password of user accounts. In order to manage an instance, control plane may perform administrative tasks on a database instance. To achieve separation of duty between such administrative users and the account used by customer, MDS relies on two features which we introduced in MySQL 8.0, system user privilege and partial revoke. This together makes sure that administrator accounts are truly immutable and can perform required action without any issues. We also have separate network interfaces, one for administrative connections and another for customer connections. In fact, each of them have their own TLS stack so as to not impact each other at any given point of time. These are some of the measures taken to make sure that the instances are secure since the inception and stay secure for their entire lifespan. So as far as the data protection goes, control plane access to a database instances is only through an authenticated and authorized local software agent. In addition to a password, which is supplied automatically to software agent without any human intervention, TLS certificates are also used as an additional layer of authentication. Again, access through control plane is only to maintain the instance, nothing else. No human has access to the host that's running MySQL database server in MDS. Further, access to data is strictly as per services privacy policy and data processing agreement, and we don't have any insight into the actual content whatsoever. So that's it from my side on the MDS security part. Thank you for tuning in and listening to us. Hope this session was informative to you. Over to you, Mike.
All right. So now I think we have some time for some Q&A questions. Let me look at the Q&A chat. Okay, well, here's one question. Can OCI MDS support help me design my security containers, et cetera? And yeah, we really can. It's really easy to do once you've been shown, and we're happy to walk you through that and show you how to connect your app. and the OK through the VCN and all that sort of thing. So yes, we are more than happy to get you going. All right, the next question, I think this is a good one for you, Hurin. What rights does the customer's MySQL admin user have or not have?
As a customer's administrative user will have all the privileges required to maintain schema, various objects within the schema, maintain users, roles within the database to make sure that access policies are in place, grant them various privileges. All those rights are available. The monitoring aspect as well, to see what's going on, the access to performance schema, the process privilege, all those things are granted to administrative user.
Okay, thank you. All right, we've got another one, and I'll take this one. How often are security updates done on MDS? So, yeah, we automatically apply security updates to ensure your data is not vulnerable. I probably should have covered that at the top. It's at least once every 3 months, but we do our updates sooner if there's any vulnerability or anything that needs to be patched sooner. Our operations and security teams evaluate critical patches on not just the MySQL database service, but everything. The Linux is running on everything is involved, and we do the security patches as soon as we can. Okay, let's see. Next question. Can programs running on servers in my own data center access MDS databases? And yeah, we talked about this. So you can connect your on-premises network to OCI. You can use fast connect to public peering or private IPsec endpoints. What we don't do, and what nobody should ever do, is expose a database port on a public IP. There are many breaches that have happened as a result of that, and a lot of the bots that are out there looking for holes just constantly hitting various things to find an open port and try things out. So no, we want you to have a good secure network connection into your MySQL database. All right, let's see, we got another question. How can I change the configuration? I think this is a good one for you, Hurin.
Changing configuration is possible either through REST APIs or through console. You'll have to involve control plane in this matter if you want to change the global configuration parameters. Some of the local parameters, of course, as I said, can be changed on a session level itself.
All right, I think this is the next one's for you too. How can I see who's logged in?
Yes, right. The default admin user, the default root user that is created for customer, has access to performance schema, which can be used to see who all users are logged in. Not just that, any kind of monitoring information that you can think of is possible.
Right. Yeah, the performance schema is incredibly powerful, and information schema as well. All right, we have a last one. How can I access? Do I have access to the error log? And yeah, you do. You can see the error log in your console, or you can touch that error log through REST API calls that are easy to make. So, yeah. So I think that's it. I don't see any more questions that we want to answer live right now. Again, we'll stay online and do some Q&A in the chat.